Attendees are in listen-only mode.
Welcome to this month's Tech Session presentation. With us we have Warren Frame. He's a systems engineer in upstate New York, big in the GitHub community on PowerShell. And he's here to tell us a little bit about revision control and how it works with PowerShell.
Cool. Thanks for having me, Nick.
Yeah.
All right. So it turns out there's actually a lot to go through for this presentation, so I'm going to try not to go too fast, but definitely slow me down if I am going out of control. So I wanted to kind of just give you guys a sort of a crash course in version control. We're going to be using Git and GitHub for that. In terms of agenda, I'm going to go through some boring PowerPoint stuff. I'll try to zip through that pretty quickly. And then we're going to jump right into a demo. We're going to look at the GitHub website, the GitHub Windows client, and then finally the Git command line. Let's see. And just as a quick heads up, all the materials for this, I'm just going to post them on my GitHub account afterwards. So that stuff will all be available.
Perfect.
So just super quick introduction. I'm Warren Frame, systems engineer in upstate New York. Long story short, I just spend my time planning for designing and building solutions, a lot of times using PowerShell. I'm out there on LinkedIn, Twitter. Feel free to connect with me. I have, a blog, a GitHub account. Feel free to check it out. Not too much exciting out there, but you might find something interesting. And then finally, the main takeaway from this slide, if you guys haven't checked it out, there's this PowerShell Slack community. And long story short, it's just sort of this chat service. And it's actually bridged with the PowerShell channel on IRC. It's kind of helpful. There's a lot of folks out there like Joel Bennett, Dave Wyatt, Kirk Monroe, Justin Rich, and even guys from the PowerShell team who are willing to, help out if you have a question. It's also kind of nice if you want to learn something. I've found that trying to help others can definitely help with that. And finally, if your boss is asking you, like, what are you doing in the chat room during the day? It turns out that when you get all these PowerShell folks in the same room, you might get some takeaways in terms of ideas or solutions to problems that you're having. So it's definitely been quite valuable. So enough about me. In terms of goals, I kind of set this up in the synopsis for the presentation, but I just want to sort of get you guys comfortable so that you might use version control for your own projects, whether that's at work or at home. And in case you missed it, Microsoft actually recently open sourced the DSC resources, which is kind of a big step, and it should be really helpful. So in the past, if you had like a DSC resource you were using from Microsoft, and maybe you ran into a bug or you had a feature request of some sort, you could actually do that yourself, right? You could just modify that DSC resource, but the problem would come when Microsoft updated that resource. Now you have to merge in your changes, and as they keep updating those resources, that becomes unsustainable pretty quickly. But nowadays, if you just learn a little bit about Git and GitHub, you can write your code, submit something called a pull request that basically says, hey, Microsoft, I'd like to submit some changes. And if they accept it, your code will actually go right into the actual DSC resource and all of the future updates. So it's kind of exciting, and it's your way you could give back to the community by improving these resources. And also to yourself, you can get better resources for your own environment. And then finally, this isn't really a big one, but I've found that a lot of times IT professionals and IT departments don't put as much value on source control or version control as they should. And hopefully, maybe you could take away some of the material here and propose using version control at work. And last off, this will not make you a Git pro. This is just a quick getting started sort of practical introduction. There are books and plenty of references that I have at the end. So before we dive into demos or anything, we kind of have to talk about what is version control. Long story short, it's just a system to manage changes to files. So I have a really quick example over here from Sergey, a guy at Microsoft, who's been really helpful in terms of motivating folks to get involved in the open source community, including myself. And anyways, so for this particular commit in Git, a commit is basically saying, hey, take a snapshot in time of my project. So in this commit, Sergey basically made a change on April 17th, so we can see who made it, when he made it. We can actually see specifically what files he changed, and it will actually show us the lines that he changed. And then I mentioned sometimes you know why they make a change. This is really up to people. Sometimes you'll find people not leaving a clear commit message. So in this case, Sergey gave a great message basically explaining exactly what his change did. I'm going to kind of make the assumption that folks at this presentation have already been sold on using version control, but long story short, some of the reasons that I personally really love it for. So we all know that with source control, you can kind of revert a change, back to how your project used to be. But one of the other handy things is you can actually just browse your project as it might have been a month ago. You don't have to revert to it. Just browse around it and maybe copy a snippet of code that you accidentally deleted, and then just move that to your most recent version. It's really helpful if you're going to maintain multiple versions. So maybe you have a PowerShell module for your support team, and you want them to have sort of a production-ready version that it's working, it's 100%, there's not going to be any issues, but you're going to want to sort of develop and write some PowerShell functions for them that might not be complete yet. So Git makes it really easy to do this in terms of having like sort of a production or master branch and having a dev branch. And we'll talk about that later. It lets you quickly compare differences, between different branches, between different versions of your code. It's really quite handy. One thing that you might not realize until you start using it is that it's a really great resource to improve your sharing and collaboration. So I have a PowerShell module out there at work, and I used to, I really want to encourage people to use PowerShell. So I'm like, hey, you guys are more than welcome to make changes to this. But I also like to kind of know what people are doing. So I switched from giving them access to it to saying, hey, maybe shoot me an email if you have a proposed change. And that's a really inefficient system. And we'll talk about how we can use Git to sort of provide, you can definitely gate your project, but you can definitely improve collaboration as well. And then finally, and I think this is probably the most important thing nowadays, a lot of modern solutions just assume that you have version control in place. If you want to start using some configuration management solutions and start moving towards infrastructure as code, there's sort of an assumption that you have a version control system. And if you want to use something like continuous integration and delivery, that needs a version control system behind it. Just to give you a quick intro to what that is, as an example, at work, if I make a change to that PowerShell module for support, I just send it to Git. Something called Jenkins, it's a continuous integration solution, runs a couple pester tests. You don't necessarily have to do that, but I would recommend it. And then it actually copies it out to the network share where everyone pulls it from. So I don't have to do anything. I just make a change to the code in a certain way, and it will just automatically get placed in the right directory. And there's some interesting stuff coming out. I think we might see a nice presentation on this from Dave Wyatt next month. Stop by PowerShell.org and look into the new community build server. It looks pretty cool.
Yeah, Dave offered to do the next tech session on build.powershell.org. Yep.
Very cool. All right, so that's sort of why you might use version control. And now we kind of just got to quickly talk about what are the different versions and flavors out there. So I'm just going to talk about centralized and distributed. Those are really sort of the only things remaining nowadays. Long story short, there's sort of these centralized systems, and I know that it says Subversion and Git in this picture, but it's a nice illustration of sort of the difference between these. When you're using a centralized solution, you're working on your own computer, right? But every single change that you make in source control, it has to talk to that server. So there's going to be a number of performance implications. If you're like sitting in a meeting writing some code and you get disconnected from Wi-Fi, you can no longer actually work with your source control. Or people use an airplane as an example. It seems far-fetched, but I've run to a large number of cases where I want to commit my changes and I don't have access to something. And using Git, you can actually do that. So with a distributed version control system, long story short, you could still potentially have a central repository, maybe GitHub or maybe an on-premise solution, but you actually do all of your work locally, and you have an entire copy of that source code, of that source control or version control repository on your computer. So all of your version control commands, they just run against your local computer, and it makes things, it's much faster, and it allows some interesting architectures. So you'll actually end up with something like a centralized version control system model if you just have like a GitHub or a GitHub Enterprise solution on site where you might be working locally, but you're probably just going to push it up to that central spot when you're done. In terms of different options that you could potentially use, there's a bunch of hosted solutions, GitHub, Bitbucket, Visual Studio Online. I found that you might end up paying a bit more for these in the sense that you have to pay per repository. So that can kind of limit you in terms of having a good number of repositories out there. And then on the other side, you have on-premise solutions. You can install, like your own GitHub Enterprise server, Atlassian Stash, Microsoft Team Foundation server. GitLab is another popular one. But these go the other direction where you're probably going to have to either pay for the solution or you're going to have something like GitLab CE or just a vanilla Git server, and that runs on Linux. So I haven't found like a super cheap Windows version of Git that you can just have as a nice Git server. So I'm hoping that at some point we see that. And then I guess before we move forward, it's really important to note that we're going to be looking at Git and GitHub, but a lot of the concepts that we're doing, they really apply to all of these different version control systems and their implementations. Let's see. So I'm not going to go through any terminology. As we go, I'll sort of try to talk through what different things are, and it is time for demos. So again, we're going to be looking at the GitHub for Windows client, but I do want to kind of highlight there's some other clients out there. Atlassian SourceTree is a great option. I have the link in the notes. I tend to use that in the GitHub for Windows client. I don't even drop into the shell too often. And then TortoiseGit is another popular one, but I haven't personally used it that often. All right. So moving to demos. So I'm just going to browse to github.com, and I'm going to make the assumption that you guys can go out and sign up for an account. It's quite straightforward in terms of, there'll be a button to sign up, and it sends you an email, yada, yada, yada. So this is sort of the front page you're going to see when you first sign in. When you first do this, you're probably not going to see as much information. One of the great things about GitHub is it's sort of a social layer on top of the version control system. So I can see, if I follow someone, I can see, maybe they star a repository that I haven't heard of before. Back when the DSC resources were released, you would have seen this way ahead of when they actually announced it. So it's kind of interesting to see new projects through that. And you can also follow specific projects, right? So if you're using Posh RS Job from Boprox or RabbitMQ tools, on site, then you might want to watch those repositories to see what's coming down the pipeline that you might have to implement at work. So as a quick example, if you want to follow someone, you're browsing around, you find a particular repository. I can click on Matt's name here, or I could click on contributors, and it will say like who are the different people who are actually publishing code to this repository. And GitHub takes a little while, and so I could pick one of these guys, Ben, Matt. I'll pick Matt. And I'm actually following him, but there'd be a big green follow button if you wanted to see what he was doing. And if you were actually on this repository using it at work and you wanted to watch it, you just click the watch button. So that's just a nice way to sort of keep up to date with what's going on in the community. Now let's talk about repositories. So this is sort of the first vocab word for Git. So a repository is basically everything that you need in terms of source control for a particular project. So I'm going to open PSExcel, and just a quick highlight. If you do want to use Excel from PowerShell, definitely check out Doug's module. This was just a copy that I made a while back. So in this particular case, I just have this module and a couple surrounding files, but it's really just the module. So what you put in a repository is really going to be up to you. This is just one module in a repository. If I go back to my account, I also have a PowerShell repository, and this is just a hodgepodge of PowerShell scripts. This might be nice if you just want to have something in source control, but it's not really related to anything else. But once someone wants to work on something with you, so at one point I got a pull request from Sergey at Microsoft, basically asking if we could separate out Invoke Parallel into a separate repository just to sort of help us collaborate better. It's really straightforward to do that. I just created a new repository, and now Invoke Parallel is out there, and realistically it's just this Invoke Parallel PS1 file and a couple tests. So what you put in a repository is really up to you. And then finally, in terms of sort of helping out the end users, definitely consider putting in a readme.md. All this is it's just a markdown file. If you view the raw contents of it, it kind of looks like if you're posting something on Stack Overflow or Reddit or another site that uses Markdown. It's just a simple way to make a nice front page for your repository. So I usually like to include like a quick overview, maybe talk through how they import the module or the function and how they can use it. It's a nice way to just sort of provide a front page for your module. Let's see. So let's move on to issues. So repositories are specific to Git and other sort of version control systems. We're going to be looking at issues now, and this is actually specific to GitHub and other bug tracking software. So this is not Git. But this is sort of a way where folks can actually interact with you. Maybe they submit you a bug request, maybe they have a question, maybe they have a feature request. And it's a great way to get involved with projects. Maybe you're not comfortable with the code base yet, and you're not comfortable making changes to the code. But if you have a particular bug that you run to or a feature request, it's really helpful when people submit these. I'd much rather have a pull request where you actually give me the code. But if all you can provide is a bug request, that's definitely helpful because there's a lot of bugs out there that I might not catch. So in this example, someone ran into an issue where there were memory utilization issues, and he sort of gave me enough info, right? He told me the command that he ran. He told me the actual outcome. It might have been nice to see, like, if he had tested it with other scenarios. But when you're submitting an issue, kind of follow the golden rule. Submit what you would expect in a bug report, like, talk about the environment that you're in, what command you ran, any specific errors you ran into. Let's see. So that's pretty much it for issues. It's just a handy way to have bug tracking for your repositories. Now we're going to look at the next vocab word. So we're in the invoke parallel repository. Now we're going to look at something called a commit. So this is really sort of like a fundamental unit in Git. A commit is just like taking a snapshot in time. So if I have a commit, my first commit, and it's like one file, Git's going to keep track of that. Actually, here, it's probably easier to show you. So I'm actually pulling up, I'm looking at all the different commits, and I can actually go back in time. So I can go back to like January 20th, and I can actually view the changes by clicking on this small SHA-1 hash, or I can actually browse the repository from way back then. So I'm going to click that, and we can kind of see, hey, it was only like 3 files back then. And I can browse the file and actually see what the code looked like at this point in time. And this is really kind of a handy thing. Like if you find yourself leaving comments in your code saying, hey, here's a snippet of code that you might need later, and you're afraid to delete those out, source control makes it really easy. You just strip these out, and then if you need to go back, you use source control. So we were browsing the file system. We can also click this little hash, and it will basically show us, okay, what actually changed on that specific commit. And we see there were a number of just small changes. Let's see. And we'll be looking a lot more at commits later. So next up, we are going to be looking at forks. Forks are basically taking a copy of someone else's repository and copying it to your account. So I have like a test demo to fork, and keep in mind you could do this with the DSC resources. I created this demo to fork repository, just pretend like it's DSC resource. I wanted to sort of illustrate the end-to-end use of like copying someone's repository, pulling it down to your computer, and then collaborating with them and pushing it back up. But for now, we're just going to use this one. And if you want to fork it, all you do is you just click the fork button. And so now we see this change. Before, it just had, demo GitHub user, demo to fork. Now we're actually in our own account, and it's telling us that, hey, this is a fork of this other repository. So at this point, it's basically I have a copy of someone else's repository, right? This might be the DSC resource that you're working on. Now you might ask, why would you have to do this? So the basic idea is that you can fork anyone's repository, assuming they've set up privileges that way, and that's sort of the default way. So you can fork pretty much anything that's out there, and you can work on it and do whatever you'd like. Maybe you want to keep that as your own project, and you don't want to push your contributions back. That's more than okay. Otherwise, you can actually submit something called a pull request, and we'll look at that later, where you're saying, hey, demo GitHub user, I have some changes to make. Would you be interested in these? And we'll look at that workflow later. I'm just kind of running through some really basic stuff. So that's a fork. All right, so when you're first getting started, you might just want to work on your own repository. So it's pretty straightforward. There's just a big green button for a new repository. And when you type in a repository name, just think of something. This is going to be in the URL. Think of something that kind of describes it. I'm just going to call this demo because I'm going to work on a demo repository. If you want to give it a description, go ahead. I have public and private because I have like a student account, but you're probably going to end up with public. And a lot of people will say, hey, just skip by the license at this point. But I want to really emphasize that it's important to at least consider the license. There's folks out there who won't be able to use your code if you don't have a license or if you have a particular license. And there's others who won't be able to contribute to your code if you use a particular license. So as an example, if you had the GPL license, someone from Microsoft might not be able to contribute to your repository. If you have questions about these, there's a really cool choose a license website that GitHub provides that sort of describes these in plain English, and it will actually describe a lot of the other licenses as well. I tend to go with the MIT license just because it's really simple and I can understand it, I think. So I'm going to end up going with that, and that's pretty much it. So at this point, I have a demo repository. That's as simple as it gets for creating a new repository. So at this point, we're sort of nearing the end of the GitHub website until later. One other important note, what we're about to do, I could just click clone in desktop, but we're going to show you how to do it with the desktop client. And then finally, when you're using the shell, if you ever need to clone something, there's a URL here that actually points to this demo repository. So let's see, we're going to close out. All right, so I'm going to make the assumption that you can go out and you can install GitHub for Windows. It's really straightforward. It's a pretty nice application. It will install this little GitHub client, and it's going to install this little Git shell. We'll look at each of these. So when you first open this GitHub for Windows client, it's actually going to prompt you for a couple questions. First, it's going to basically ask you for your username and password from GitHub. That's pretty straightforward. Next up, it's going to basically ask you for something to configure your Git config. And the whole idea is when you submit a change, a commit to Git repository, it keeps track of your user and your email. If you want to keep that email private, just use something in this syntax, and I'll have that in the notes as well. It'll also probably ask you, like, where do you want your default clone path to be? I pick like a really straightforward path here just so the shell looks a little nicer later on in this demo. So that's that. So you'll have nothing over here when you first start, and to get started, we're just going to click the plus button. And in this case, we want to clone. So we talked about a fork, right? That was copying a repository from someone else's account to our account. Now we're going to copy a repository from GitHub to our own computer. So I want to clone demo, and notice that I can actually clone anything, right? I can clone this fork that we had forked. I can clone this demo. At this point, it doesn't matter if it's a fork or your own repository. You just clone it. And so default, it should pick SC. And that's pretty much it. So now I should be able to see the files in here. And at this point, it's just a license. So let's see, we're just going to make a quick change. So maybe you've created your new repository, you want to add like an existing project to it, or just create a new project. I'm just going to go back and just copy a file. So one of my favorite new commands is join object, and I'll just toss that in there. So if I go back in here, GitHub client will see, hey, he added a file. So we have to take a quick break here and talk about some concepts in Git. So in terms of like locations, Git keeps track of a few different things. So first off, there's what you see. This is the working directory. What you see doesn't necessarily reflect what Git's going to keep track of. So I have this working directory. I've copied a file here. Git has this thing called a stage or an index that it basically uses to say, hey, what do you want to actually go in source control? So in the GitHub client, this is reflected by this little checkbox. If I uncheck it, it's not going to be staged. If I check it, it's going to be staged. And we'll pick up more on that with the Git shell. But in this case, we're good to go. We have added a file. We have staged it with that checkbox. Now I'm going to write something called a commit message. This definitely try to explain what you're doing when you write a commit message. It can be really helpful for folks who are working on this down the road, or just for yourself. Maybe you forgot what you were working on. So in this case, it's not too important, but I'll just say added join objects. And of course, I can't type. Why am I typing in a demo? And that's pretty much it. So at this point, join object is in source control. So now let's do one more quick edit to show you kind of what it will look like when you're actually working with individual files that are already out there. I'm going to make some sort of superficial changes. Move a bracket and add some periods. And if I hop back in here, I had moved to unsynced and changed. We'll look at what that means later. So at this point, this GitHub for Windows client sees that I've made a couple changes to this file, and it checks it automatically. I don't even have to think about that. And you can actually see it kind of highlights in green the specific period that I made, so I can kind of see, what did I actually change. It's really quite helpful. So now I'm just going to say, updated help, and I'm going to commit this again. So at this point, we're going to have 2 commits out there. Now, it's really important to note that what we're working on our computer, unless we specifically say, hey, send this out to GitHub, it's not going to do that. So if I refresh this, there's still just a license out here on my actual repository. So at this point, the GitHub client is saying, hey, you have 2 unsynced commits that you could push up to GitHub. You'll see a little sync button here. It's got a little blue badge. And so I'm just going to click that. And what this is going to end up doing, it's just saying, hey, sync this repository between what's on my local system, the local repository, and what's on GitHub. So first, it basically runs something called git pull -- rebase, and that's going to pull everything down from GitHub to my computer. And then if I have changes on my computer, it's going to run git push, and it's just going to push those changes up to GitHub, basically syncing up my repositories. And so if I was working on another computer and I had made some changes on GitHub, or another person had made some changes, there might be a blue badge with a down arrow, and that basically means, hey, there's some GitHub changes that you can pull down. We're not going to talk much about. We're actually not going to talk about merge conflicts in this. They can seem kind of scary, but there's a lot of sort of interactive demos that can kind of walk you through what happens when 2 people modify the same file. It's really not too bad. You basically just kind of edit things out and then pick which file you want. Okay, so that's pretty much it. So that's a pretty straightforward workflow, right? I made some changes in the file system. I'm used to doing that. And then all I did when I was done, I committed it, I saved it. I took a snapshot of the version control at that point in time, and then I pushed it up to GitHub. Now, it's really important to note that pushing it up to GitHub is actually optional. If you'd like, you could just keep this locally. So maybe you don't have a central version control Git server at work. You could still run something called git init and create a local repository on your computer, and have it completely unrelated to GitHub. And there's plenty of interactive demos. I have a couple links for those if you want to learn how to do that just on your own local system. So that's the basics of the GitHub for Windows client, and we'll be coming back here when we talk about some more advanced concepts. So let's minimize that. And so we just looked at the GitHub for Windows client. Now we're going to dive into the shell. So this git shell shortcut, long story short, for the git executable, I believe it's using msysgit, and it loads up the posh git module, which will provide you a handy prompt that we'll see in a moment. So right now I'm not in a particular repository, so I don't really see anything special, but once I change directories to this demo repository, all of a sudden we start to see some colors. So that is that. I guess it's important to note before we go any further, I actually usually prefer the ISE, but it turns out that git.exe it has some dependencies on the console host, and there are some folks who have worked around those, and I have a link in my notes on that, but I usually just stick to this shell if I really need to. And then definitely check out Windows 10 or Conemu if you want a better console. Everything before that was kind of painful to use. And I guess before we even dive into using Git executable, we really have to mention, so we're all PowerShell users, right? We're really familiar with, there's some handy conventions in PowerShell. I learned just the basics of PowerShell syntax, how to get help, how to explore, and that applies to all the different parts of PowerShell. Now, we're going to go backwards. We're going to go back to executables, where every executable has its own way to do things. So in Git, I'm going to have to do git-help. If I want to read about the help. And it's going to be a bit archaic if you're coming from PowerShell. So just a quick heads up, there's some folks, including Joel Bennett and Justin Rich from the PowerShell Virtual PowerShell user group, who are kind of working on PowerShellizing these into, your friendly verb-noun syntax. And that's out on GitHub, and I have a link for that. It's not ready yet, but it's something to stay tuned for. So at this point, let's just run through sort of some similar workflows to what we did above, except for at the shell. So in this case, I'm at the command line. I'm going to create a new file. Now, in the GitHub Windows client, we had that little checkbox that added it to the stage. So at this point, the shell is telling us, hey, you have one file, and it's in red because it's not staged yet. So if we do, oh, geez. Sorry about that, technical difficulties. So I'm going to run a quick command, git add -A. Again, it's capitalized. It's not PowerShell. It is case sensitive. This is going to say, hey, any changes I've made, I want those in the staging area. So it's just a quick shortcut. So I've, kind of checked the checkbox in the GitHub client at this point. It's ready to go. It turns green. It's saying, hey, I have one new file. The tilde would be if I had a changed file, and the minus would be if I had a file that was removed. I'm going to run git commit -m, and it's basically saying, hey, create a commit and give it a message, and I'm just going to say I'm adding a test. If you get deeper into Git, you'll see that every single commit has a SHA-1 hash, and this is just the first few characters from that. It's just sort of a shorthand for referencing it. It's not going to be really important for what we're doing today, but it's just something to keep in the back of your mind. So you see master turned green. What this means is basically that our repository on our local machine is ahead of GitHub. So if we want to sort of push that sync button like we did in the client, we're going to do a git pull -- rebase, and there's really nothing out there, so it's probably going to tell us, hey, you're up to date. And then finally, we're going to push our changes. So we've pulled new things down from GitHub, and if I had had changes out on GitHub, it would have pulled them down. And now I want to push the new test file out to GitHub. And we're now blue again, which means GitHub is up to date. And if we browse out there, we should see everything. So now we have that join object, and we have the test that we just added. And if we browse through the commits, we'll see each of those individual commits that I created. All right. I probably wanted to stay there for later. Sorry about that. Okay, so that's like the super basics of using the shell. At this point, we're going to get into a concept that kind of can throw you for a loop if you're not using it. But once you start to use it, it becomes pretty straightforward. So we're going to look at something called branches. So if I take you out to the fork that we created, demo to fork, let's see, oh geez. You'll see on the GitHub Windows, the GitHub website, there's a thing that says branch, and right now it's saying that we're in dev. There's also a master branch. And if we flip back and forth, we see these are actually a little different. So in the dev side, maybe there's some extra commands that they're working on that aren't quite ready yet. So a branch is just sort of, it's a way to have, like, I don't know, have you ever copied a PowerShell module to just an entire new folder and you're kind of working on it separately? This is a handier way to do that. You can still have it in source control. It makes it much easier to compare things and to merge them back in. So in terms of branches, so when we were making those commits, I mentioned that's like a snapshot in time, right? It's similar to VM. You might snapshot a VM. All that a branch is it's like a post-it note on one of those commits. So master is a post-it note on the latest commit that we just made. And so let's see, so it's a post-it note. Oh, geez. Sorry, I've lost track of where I am.
Yeah, if you come from the computer science world, it's really just a pointer, just a way to point to some sort of resource.
Cool. Yeah. Thanks, Nick. So that's what a branch is, right? There, you could have a master branch, a dev branch, a production branch, whatever have you. And the only reason that they call this master, that you'll see this so often, is that when you first create the repository, that's just the default name for the first branch that's created. Now, at this point, we also have to add another concept that's kind of, I don't know why they named it this way, but long story short, there's something called head, and head is a pointer to one of these branches. So the branch points to a particular commit, right? It points to a snapshot in time, and head points to like it's where your working directory is right now. So I'm going to actually I'm going to fork the demo to fork repository because that has two branches. Again, I'm just going to do it in the GitHub client because that's a little easier. Demo to fork, I'm going to clone that down. So I'm cloning demo to fork, and this is the one that has dev and master branches. And one really quick way to kind of highlight, what's actually going on under the covers. I'm going to pull up this demo to fork repository. So if I flip from dev to master, it's actually under the covers going to be completely changing out my working directory. So if I flip back to dev, all those files will reappear again. So that's just kind of like a quick way to see what's going on. All right, so let's switch out to that. All right, so now we're in the dev branch. We see that it's not master anymore because we actually, in the GitHub client, we've switched to the dev branch. We could take a quick look, and don't be afraid of that .git folder that you're going to find in every single repository. That's just all of the files that are used under the covers. Maybe don't go modifying things that you're not familiar with, but there's nothing wrong with actually going out and seeing what's inside these files. So you can actually read, what's in head. So what's this really complicated thing called head? It's literally just saying it's pointing at dev. And this all sounds really complicated, but once you actually start using it, it makes more sense. So if you want to list the branches, we had the pull down in the GitHub client. You just do git branch, and you could do -- all if you want to see your remote branches, like your GitHub branches. So at this point, we're in dev. Let's make a change. So pretend we're using one of the DSC resources from Microsoft. They actually prefer that you do your work in that dev branch. And I should also mention, these are case sensitive as well. If I had switched to dev, lowercase dev, it would have created a new branch with a lowercase dev. So case sensitivity in Git, it's important. So we're going to make some changes. Pretend you're, modifying the DSC resources from Microsoft. Let's see, copy. I'm going to create a new item. I'm going to add it to the stage, and I'm going to commit it. Right, so we added a file, we added it to the stage, we committed it, we included information on what we actually changed, just adding a file. And at this point, let's see, where are we? We can kind of flip back. So I was hitting the drop down before. If you want to do that at the command line, it's git checkout master. And that will flip me over to master, and if I do dir, it's only going to show me a few files. I can git checkout dev, remember case sensitive, and it will flip me back there, and again, I can see all of the files in that dev branch. So this would basically be if I copied a separate repository and I just kind of wanted to work on it separately. So at this point, we've made a change, and I'm going to pretend that's a change to one of those DSC resources, and we're going to push it up to GitHub. But before we do that, this isn't really important to this workflow, but you can't have a Git talk without mentioning merging. So if we want to actually, move these dev changes into that master branch, we can do something called a merge. So first I'm going to go to that master branch, and all I'm going to do is I'm going to do git merge and the name of the branch. And that's pretty much it. So now my master branch is, pretty much on par with my dev branch. Again, when you're working with the DSC resources, you're probably not going to need to do this, but just sort of as a heads up. All right, so we've made our changes. Now we want to send them up to GitHub, right? So at this point, nothing has changed on GitHub. Nothing has changed on the actual official repository on GitHub. It's all on my computer. If I do git push -- all, it's basically going to push all of the branches that are on this particular repository that are set up. If you create your own branch, and I have some notes, what the heck, I'll just do them really quick. So let's pretend you want to create a quick branch. We're going to do that. What the heck? The command for creating a branch is just git branch and then the name of the new branch. So I created a crazy test branch, and then I switched over to it, and you'll see that my prompt changed to reflect that. I created a new item. Now I'm going to stage that. So we're adding, this is just a third branch. Don't ask me why you might do this. You might find it helpful in one of your workflows, but I'm guessing for an IT professional, you're not going to be doing too much branching apart from just having a dev and a prod. And finally, we're going to do a modified version of that git push, we're basically going to say, push it up to GitHub, and that little U option there is going to sort of set up the branch on the GitHub side for Crazy Test. So at this point, if we browse back to demo to fork and just refresh, we should see all 3 branches. Now we have master, we have dev, and we have a Crazy Test. So that is pretty much it. In terms of a workflow, all we did was we forked this repository, then we cloned it down to our own computer. So we copied it from someone else's account to our own account. Then we copied it from our GitHub account to our computer. Now we just pushed it up to our account. Now we have to say, basically let this demo GitHub user know that we have some changes for him. And that is called a pull request. Let's see. So now we're going to be back in sort of the GitHub client. Forks and pull requests are specific to GitHub and different sort of solutions out there. They are not specific to Git. So let's see. So we're on our fork, right? And notice how we have these new green buttons. They basically say, hey, compare and pull request. This is basically a way for you to say to whoever's repository this is, hey, I have some changes for you. So I am going to submit one. Actually, I'm going to skip by those. I'm going to click this little green button because that's a little off. And basically, I'm going to say I want to push from this dev branch that I have to this dev branch on demo GitHub user. This is sort of like if you were using the Microsoft DSC resources, this would be like PowerShell / and then whatever the DSC resource is. It's important to note that if we had been in a different branch, you might have to flip this over to dev. We want to make sure that we're submitting this to the dev branch. And all we do is we just hit create pull request. This is telling us that it's good to merge. And this is basically just going to kind of send a note to that demo GitHub user. And kind of follow the golden rule again. I'm making a really sparse note here, but you want to kind of explain why you're proposing these changes. I don't know, if you had a project out there and someone submitted you, basically like they reformatted the syntax of your whole project, you probably wouldn't like it, so maybe don't do that. If you got this request for 500 new lines with no explanation of what they did, that might not be very helpful. So definitely think of this from the author that's going to have to read your pull request. But in this case, it's just very simple, so I'm not going to include too much information. I'm going to click Create Pull Request, and that's pretty much it. So now we kind of have this stream. It's a pull request. I can leave more comments. I can explain some reasoning if he asks a question. If I have a modification and I have this pull request open, I can actually make changes on my computer and push them back up to GitHub, and they'll automatically be added here. So at this point, we're going to kind of switch it over, and we're going to take a look at this from the viewpoint of Microsoft or whoever has this resource, right? If you publish your own repository and you're accepting contributions, this is something that you're going to want to know how to do. So I'm going to log out and log in. Hopefully I've remembered the password. Demo, GitHub user. Ooh. Nice. Okay, so I'm in the account that had this project that we forked and then we made some changes to. So I can see, hey, I have some unread notifications. So if I look in here, I can see, hey, someone just pushed a fork to me, just pushed a pull request to me. And I can click on that. No, I clicked on the actual repository. I can click on the actual pull request. And this is basically giving me an overview. So I'm now the author of this module, and someone has proposed a change. They didn't do a very good job explaining what it was. I can actually see each of the commits that they made to it, and I can review all of the files that changed. In this case, there's not too much there, but if they were making changes to these files, you would see sort of the green and the red text that we saw in those other messages. So that's pretty much it. I could leave a note and I could say, hey, could you make a couple changes before I merge this in? Or if I'm happy with this, I can just say merge pull request. If you get into a really complex scenario with a lot of people contributing, whoever the maintainer for this repository is, he might have to go to the command line to merge it in. But for small PowerShell projects, most of the time you just can merge it right in. So at this point, I can give this basically is sort of like the commit message for this merge. I'm going to say, yeah, I want to do this. And at this point, the changes that Rambling Cookie Monster posted have been merged into my repository. And this is really great because people can submit changes that can improve your projects. I've learned a lot from having other people sort of help me out by proposing changes to my projects through pull requests. So it's quite helpful. So if we browse around, we'll see that new file, some dev code, was added. And this is just a quick overview. We can see what the commit message was when this was added. So just to kind of reiterate that workflow, we forked someone's repository, we cloned it to our desktop, with the GitHub client. We made the changes in the file system. We committed those changes in the GitHub client or the shell. We pushed those up to GitHub with the sync button, and then we just submitted a pull request. It seems like, maybe it seems a little complicated and convoluted of a workflow, but once you start doing it, it really becomes second nature. This is really straightforward stuff. It's just a matter of, starting to use it, and it will really become second nature. Let's see. Geez, so this is progressing a little faster. So I think that is mostly it. I definitely recommend you guys get involved with the PowerShell community on GitHub. You can help improve the community by, improving and submitting these pull requests and issues. If you have a project that you need help with and you publish it on GitHub, you might find that someone interested in that project actually submits you pull requests. And that's really how I got into this, and that was like not very long ago. What else? If you do end up contributing to the DSC resources, I've included some handy notes from Microsoft. So if we just hop off really quick, DSC resources, I can actually look this up, and it's going to look in my repository. So there's a PowerShell organization out there, and it has this DSC resources repository. And you'll find that there's some links in here. It kind of describes the repository structure. And one of the links is basically a contribution guideline. And this will kind of walk through, they have a link to getting started with GitHub, and it will walk through sort of the cycle for creating these forks and submitting pull requests. And I think that's most of it. There are, so here, let's pull back up the presentation. Okay, cool. So this is sort of the last slide, and this looks crazy. Like, what the heck is all of this reference? But long story short, I just wanted to include some of the references that I've found helpful in the past. I definitely did not read through all of these. You just might find it helpful. If you have a quick question, you can kind of skim through one of these that makes sense. And I'd find these interactive guides, they are quite helpful. They're basically just, they're basically quick guides that you can actually run like in a browser. So if I go to try.github.io, it's going to pull up like a fake little prompt and walk me through a lot of what we just did. It's really a great resource. So I think that's pretty much it.
Yeah, actually, Warren, we have a couple questions.
Cool.
Yeah, so actually somebody made a comment. There is a Windows version control. You had mentioned earlier that you didn't know of any. SCM Manager seems to be one of them. People were wondering, how do you organize your PowerShell scripts? Do you create one Git repository for each script? Do you group like scripts together to create a repository?
Cool. So for that one, it's really oh geez, I'm kind of logged into my other account. Let me just log out because it's a little easier to browse. Sign in. So when I first started using GitHub, I just created this PowerShell repository, and I was like, hey, I have some things I want in source control. I'm just going to dump them all in one repository, and that works. Like if you just want source control for just a couple files that you have out there, this might work for you. I did mention, so like at one point, Sergey from Microsoft wanted to sort of collaborate on this, and he suggested separating it out. Right, because if he's working with me on this, I'd end up like giving him access to this whole repository, and there's a bunch of stuff that he really doesn't care about. So I ended up separating that out to the Invoke Parallel repository, which is literally just like the whole purpose of this is just this one PS1 file. So it's kind of up to you. You'll also find some of the continuous integration solutions out there might sort of dictate what you're going to end up doing. As an example here, so I have this invoke parallel module, right? If I make a change to this, what it actually does is it comes up to GitHub, and then something called AppVeyor, and the DSE resources do this as well. Something called AppVeyor basically runs some pester tests that I've written, and you can actually see them running here. So it basically, you know, it downloads pester, and then it runs these pester tests. So having it out in its own separate repository lets me target my, my pester tests, or maybe I have a script that deploys this out to the PowerShell gallery if those tests succeed. So some of those downstream processes might dictate if you want to separate these things out. Yeah.
Some people were wondering whether you personally, do you use the command line or do you use the GUI tools provided by GitHub in your day-to-day workflow?
So I won't lie, like I love PowerShell. I use it every day. I probably spend maybe 75% of my day in front of the ISE. But for me, like when I'm making changes to these, my workflow, it's really straightforward to use this client, and then at work, because I'm flipping back and forth between GitHub and we have Atlassian Stash, which it turns out is free for nonprofits, so that was fantastic. I use SourceTree, and I kind of like the ability to see the changes in this GUI. So if I'm making a commit, I can see like what can I do the history? Yeah. So for me, it's kind of handy, like I'm making a commit, I can kind of see like what I changed, so then I can maybe provide a more specific commit message. And then when I was making that commit message, if you're at the command line, doing new lines and writing longer commit messages can be kind of a pain. So realistically, I don't dive into the command line until things get a little screwed up, which thankfully hasn't really happened too much yet. I do include some links on some workflows that you can follow if you do find things running into trouble, but realistically I'd say probably 99% of the time I'm just using the GUI client, as sad as that is.
No, not a problem. Yeah, I remember when I started out with Git, I always I referred to the Pro Git book. I believe the guys are from GitHub that wrote the book, and great resource.
Yeah, in that book, like, don't be intimidated by it. Like, I think it was 570 something pages.
Right.
But even just the first 2 or 3 chapters are a really great introduction to just sort of core Git concepts.
Right. Yeah, it took me 2 or 3 times reading the first couple chapters to really understand, because I didn't really have any experience with it. But now, really, it's a great read.
Definitely. And then I kind of included a couple down here. Some of these will look a little heavy duty, but they include some potentially helpful pictures that actually show you what's going on under the covers. Like this one, don't let it scare you that it says computer scientists. It kind of tells you what's going on behind the scenes, which, personally I find it a little helpful to know what's actually going on under the covers. But yeah, so.
All right, and I think we've answered the majority of the questions. So thank you, Warren, for coming in and show us how Git works.
Awesome, and apologies if I was going a little too fast there. Thanks, guys.
Nope, it'll be up on YouTube. We can go and we can slow it down if we need to.
Excellent.
And next month we're going to be having Dave Wyatt present on continuous integration, and then in September we'll have Mike Robbins doing advanced functions. So look for updates on PowerShell.org for more information.
Cool. Right. Thanks, Nick. Thanks, everyone.
Thank you, Warren.